the second derivative test to determine which critical numbers, if any, give relative extrema. So first off, when it says which critical numbers, just because you're using second derivative test, critical numbers still come from the first derivative. Still where it is 0 or undefined. And it looks like 0 is a critical number and 2/3 is a critical number. So again, even though I'm doing second derivative test, I need the critical numbers from the first derivative. Does that make sense? So I'm going to show you one of our memes I had up a couple weeks ago because I think it visualizes that. But if you're using the if you were using the first derivative test, you would plug in numbers around and plug in the first derivative. The second derivative test says plug these critical numbers into the second derivative. So I need the second derivative, 6x. So if I plug in 0, well, that's unfortunate, but if the second derivative is positive, we know it's concave up. If it's second derivative negative, it's concave down. If the second derivative is 0 or undefined, I don't know if it's concave up or concave down. So this part of the second derivative test fails.
Wait, would it not be 6x minus 2?
That helps. But yeah, sometimes the second derivative test does fail. But the minus 2 makes this negative. So if the second derivative is negative, is that concave up or concave down? Okay, so if 0 is a critical number, and I know it's concave down, then this guy must be a relative max. So instead of thinking about it increasing before and decreasing after with the first derivative, knowing that it's a horizontal tangent line, critical number, and is concave up, you get the same information. Okay, if we plugged in 2/3, that would be
2.
4 minus 2, which is 2. So if the second derivative is positive like that, it's concave up. So what does that tell us about that critical number? It's a relative. Second derivative test achieves the same thing as the first derivative test, but it uses the second derivative.